Hello people, we from this side. So we are gonna discuss about some important MCQs for chapter motion. Okay, in class 9 science for science olympiads and CBSE also. We can. This is important for class 9 science. Okay. So the first question says, which of the following is not a characteristic of displacement? Characteristic of displacement. Okay. So the first option is it is always positive. Like, okay, we'll consider this. Uh, let's go to the fourth option. It says its magnitude may be less than or equal to the actual path length of the object. First of all, displacement is a vector quantity. If is a vector quantity, so it can have magnitude and direction. It have that way. So it can be zero. Yeah, it's a possibility, and its magnitude may be less than or equal to uh, the actual path length of the object. So distance equals to displacement. It can be a possibility. It's saying that. Okay, but the first option says it is always positive. As I've said, it is a vector quantity. So vector quantity can be positive and can be negative. Okay, it can be positive or negative. So uh, this option is wrong. This is wrong. So this is the correct option for this question is the answer, but the option is wrong. That's why it's a correct answer. So let's go to the further question. The average velocity, of a body is equal to the mean of its initial and final velocities. Okay, the acceleration of the body is uh, uniformly variable, zero. Okay, so the term uniform means constant. Okay, I mean the value is gonna be same throughout the entire system. So uniform means same. Okay, basically it's same, and variables means it can change. Okay, like we take variable a, so its value can be anything. And uniformly variable, like uniformly changing. Okay, uh, it's changing in the same direction, or but it's changing, the value is changing in a same pattern. And zero means zero. So the question is, average velocity of a body is equal to the mean of its initial and final velocity. The acceleration of the body is uniform, because if the velocity is uniform, okay, that's how we can calculate its mean by initial and final. We are adding that and time taken, like the formula will be average velocity. Okay, I'm writing here average velocity is equal to initial plus final upon time taken. You know the formula of velocity. Speed is equal to velocity is equal to distance upon time. So that's displacement upon time. That is the thing which I am applying here. Time taken. So time taken. So the correct answer is uniform. Okay, I hope your doubt is clear, where a is constant. Okay, uh, okay, acceleration is constant. Now going to the third question. Third question says a body whose position with respect to surrounding does not change is said to be in a state of what? Rest, motion, vibration, oscillation. Obviously it's going to be rest, because the body's position with respect to surrounding does not change. It's at a stationary position. It's not moving anywhere. So obviously it's when an object is not changing its position with respect to surrounding and time, it is said to be at rest. So now coming towards fourth question, which says in case of a moving body, displacement is greater than distance. B says displacement is smaller than distance. uh, C, displacement is greater than or equal to distance. Okay, uh, D, displacement is smaller than or equal to distance. Okay, or displacement is smaller than or equal to distance. So we know displacement is the shortest distance. Okay, it is the shortest distance between final and initial point, and distance is the actual path. Okay, actual path covered by moving body. When a body moves in a straight line, then the distance and displacement would be same. Okay, if it moves in a straight line, like if the body moves in a straight line, so distance and displacement will be same. Okay, so there is no coming back. So then displacement would be if body moves in another trajectory, like straight line path, then displacement would be less than actual distance. Okay, like if it comes back in the same direction, so the displacement will be less, okay, than the actual distance, because distance is increasing and displacement is decreasing. The distance cannot decrease, okay, if the body is in motion. So less displacement would be less than actual distance. For example, a body moves in a circle. Okay, a body है, it's moving in a circle. Okay, after completing one cycle, its actual path covered would be 2 pi r. Okay, circumference area of a circle is 2 pi r. Okay, but the thing is, distance is covered, which is 2 pi r, but displacement is 0, because the starting point and the end point is same. And I've said the shortest distance between starting point and end point is the displacement. So this is the difference between distance and displacement. That's how we can say displacement can be smaller than or equal to distance, and the option D is satisfying this condition. Okay, displacement cannot be greater than distance. Okay, somewhere it can be smaller than or equal to distance. So that is the answer for this question, and we solved 4 questions. I'll meet you in second part of this session. So thank you.